Hi everybody, I'm Jalal Kazempour. I'm postdoc working at DTU Elma Group, and I'm working on stochastic market clearing and proposing an adequate pricing scheme per scenario. In this study, I'm working with Pierre Pinson from DTU and Benjamin Hobbs from Johns Hopkins University. Well, the story is that the large penetration of stochastic generation sources like wind power and solar increase the level of uncertainty in the system. So we need higher level of reserved and flexible sources in the system. And also to cope with production uncertainty in the power systems, we need new regulatory mechanisms. And one of the potential mechanisms is to use stochastic market clearing instead of a deterministic one. Well, the story and the foundations of stochastic market clearing is to clear the market stochastically one day advance in day-ahead market, considering all potential operation conditions in the real time. And from mathematical point of view, we have an existing model which is very common in the literature, and it's a single optimization problem whose objective function is to minimize social cost in the day-ahead market plus expected social cost in the real time. And the constraints of this optimization problem is all generation side limits, transmission limits, and energy balances per node. From mathematical points of view, this existing model, this single optimization model, is equivalent to an equilibrium model in which each player of the market, I mean each conventional generator, each stochastic generator like wind, grid operator maximize its expected profit in day-ahead and real-time markets. And at the same time, each load, each elastic load, minimize its expected payment in the day-ahead and real-time markets. Note that this equilibrium model is symmetric because every player use the same strategy. I mean, they minimizes or maximize its expected objective. And also, since the number of variables and equations are the same in this optimization problem, so we have a single solution. And since the day-ahead and the real-time markets are arbitrage, so the day-ahead price is equal to the expected real-time price. So this is an existing model in the literature. This model, this existing model, guarantees two short-run properties in the market. The first one is the cost recovery for all generators in the market, but an expectation. It means that every producer, either conventional or stochastic, gains non-negative profit, but an expectation. And the second property is that the market is revenue adequate. It means that the market operator never faced with financial deficit, but an expectation. It means that if, for example, we have 5 scenarios in the real time, we may lose, for example, a producer may lose money in a single particular scenario, for example, in the third scenario. And this has been highly criticized in the literature. So the idea of our study and the main message of this talk is to propose a new stochastic market clearing scheme which is adequate per scenario, not an expectation. To that end, we proposed a new equilibrium model in which each producer, either conventional or a stochastic generator like wind, maximize its profit per scenario, not an expectation. And grid operator as well, it maximizes its profit in per scenario. But we didn't include the problem for loads. This implicitly means that the loads are players who should pay for the uncertainty cost. This equilibrium model, this is our proposed model, is asymmetric because the strategy of all players are not the same. We don't consider any strategy for the loads. And since the number of variables here in this model is higher than the number of the equations. So we may have multiple solutions. And also, the day-ahead price in this model is not necessarily equal to the expected real-time price. But since we have multiple solutions, finally we propose a single mixed integer linear optimization model whose objective is to minimize expected demand-side payment and whose constraints are our asymmetric equilibrium problem. This means that among all potential solutions for our equilibrium problem, we select the one that with the minimum demand-side payment. So this way, we proposed a stochastic market clearing model that provides the revenue adequacy for the market and non-negative profit for all producers per scenario, and we proved it mathematically. Also, compared to existing model, the demand-side payment is higher. And the only disadvantage of this proposed model is that we need to solve a mixed integer linear problem instead of a linear one. Thank you so much.